Okay, this notes for 2.5, it says solving formulas, and if you just kind of looked ahead, you see lots of variables on this, and sometimes these are called literal equations. And you're going to use this most often in your science classes when we have big formulas like PV equals nRT. So you've got an equation like this, you want to solve for a variable. Or h of t equals v sub 0 t plus h sub 0. We've got this equation, we're going to solve it for just one variable. So you see this all the time in chemistry and physics and in your science classes. So what makes this challenging is you have to actually use your algebra skills. And so if we look at this first one, we're going to solve this first one for W. So we're going to use reverse order of operations on everything that we're going to do. So if I write them over here, so parentheses or grouping, right, and then exponents, and then multiply and divide, and then add and subtract. But what I want you to think about is we want to move everything that is not touching what we're trying to solve. Our variable that is being solved. Okay? We want to move everything that's not touching that variable first. So if I look at this, I'm solving the W. So I'm going to move everything that is not close to or touching the W first, which means I'm going to move this minus 2L. And this is our perimeter formula. Perimeter equals 2 times length plus 2 times W. So perimeter of a rectangle or a square. So to do this, I'm going to just subtract 2L from both sides. Now, because these variables are not alike, I'm literally just going to keep it, 2L. And what's left is 2W. So when I do this, don't think that I have to combine it. If I don't have an L over here, I'm not going to combine it. So I'm using just exactly the same thing with combining like terms. I want W, so I divide by 2, which means I have to divide this whole thing by 2. So what I'm left with is W equals P minus 2L over 2. And this is what I'm looking for. That's my final answer. Now, I cannot cancel these two 2's. And we've talked about this before. This doesn't cancel because I don't have a 2 over here. If I can't factor out a 2 on the top, then I can't cancel it. Okay? So here is our area of a circle formula. Area equals pi r squared. So what I'm looking for here is r squared. Well, there's no plus anything or minus anything. So the first thing that I'm going to do on this is divide by pi. So when I divide by pi, these two pi's are going to cancel. So what I have is r squared equals a over pi. Nothing combines because they're not like terms. Now, r is not by itself. So we've done this. The way we solve a squared function is we take the square root of both sides. So my final answer on this guy is r equals the square root of a over pi. The whole thing is underneath the radical. Okay, so number 3 is easy. I'm going to pause the video. I want you to go do number 3. So this is an equation of a line in standard form. So go solve this one. Come back. All right, you've done this a million times. So we put this in slope-intercept form. So we move it, you move the 3x. Now technically, I could have put this minus 3x at the end, but since I know that this is an equation of a line, I'm going to put this in slope-intercept form. It's important when you divide, you're dividing by -5. All right, now we know this equation. This equation is equation of a line in point slope form. So I have a point, 2, 3, and I have this slope right here at 4/5. So order of operations says that I'm going to do anything with multiply and divide. I have to move this first. So for me to move that, I have to multiply this on the other side. Well, when I multiply this by the reciprocal, I have to multiply the whole thing by the reciprocal. So what I end up having is y minus 3 on the left side. And I put that in parentheses because when I multiply this side by 5/4, I have to multiply this side by 5 over 4. And this gives me x minus 2. All right, let me talk about this again. So because I'm multiplying this, I want to get rid of this first because I'm looking for the x. So whatever I do on this side, I have to do over here. So if I multiply by 5 over 4, so I multiply by the reciprocal to clear the fraction, I have to multiply this side by 5 over 4. But if I multiply just by 5 over 4 and I don't have it in parentheses, then normally what happens is it just gets tagged onto the y, and that's not the case. Okay? So now I'm going to distribute this, and I would have 5y over 4 minus 15 over 4. So if I distribute this to both of those terms, that's what I get. And now since I'm solving for x, I'm going to add 2 to this side. So if it's minus 2, and I move it over here, I'm going to add 2. Now when I add 2, I'm going to actually erase this, and I'm going to make this 8 over 4. And the reason I did that is because I'm going to have to add these two fractions up, and so I might as well just make it a common denominator now. This guy doesn't change. It's a y term. So I have 5y over 4, and when I add these fractions, I'll have minus 7 over 4. So denominator stays. Numerators, in this case, are going to subtract or add a negative number. So I have negative 7 over 4. Okay, so those first 4 were fairly simple, right? There's a lot of math involved in it, but it's fairly simple. Now these are going to get a little more complicated. So what we see on this one is I have a volume equation, and I have a b in this term, and I have a b in this term. So the first step as you solve these is whatever you're solving for. So b, I have to have this on both. Sorry, I do not want to do that. I'm going to change this. Hold on. I don't want it on both sides. On one side, sorry, on one side of the equal sign. Okay, well in this case I have it both on one side of the equal sign. I'm solving for b, so I want b on one side of the equal sign. I have this. So this is step 1. Step 2 is that I'm going to factor b. So I'm going to rewrite this, and I'm going to have 1/2 BH plus BR equals V, just because my brain works better this way. You don't have to do that step. All I did was flip these. I'm going to factor B out of my equation. When I do that, I have 1/2 H plus R. All right? And now this is multiplying. So if I'm multiplying this, then to get rid of all of this that doesn't have the B in it, I have to divide. So I have V divided by 1/2 H plus R. Now, this is funky. I can't have a fraction in a fraction, and I absolutely can't convert this into a decimal. I can't have a decimal in a fraction. So what I'm going to do is I'm going to multiply this whole thing. I'm going to multiply the top by 2 and the bottom by 2. And I do that so that I can get rid of this 1/2. So whatever I do to the bottom, I have to do to the top, because I know 2 divided by 2 is 1. So it's almost like I'm multiplying this whole thing by 1, but it's not really 1. It's really 2. So if I multiply the top, I get 2V. If I multiply the bottom, I'm distributing. So this 1/2 H now is just H. And this plus R is now plus 2R. So what I'm doing, these aren't exponents, I'm distributing this on the inside. So I have 1/2 H times 2, and then I have 2 times R. So this is my final answer. Now, technically, what I could have done is I could have done this step of multiplying clear up here at the beginning. And if I multiplied this all the way through, I would have had 2V equals BH plus 2BR. And if I would have done this, then I would have ended up with, when I factored it, I would never have had this fraction. So that would have been another option, is to multiply that through in the beginning. Okay, number 6. So on number 6, if we go back over here to our directions, we want b on one side of the equal sign. Well, we said b because we were solving for b. Well, we're still solving for b on this one, but we're solving for uppercase. So I'm going to move everything around. I'm going to have ab plus bc minus 3b equals negative 10. So I move this 10 to the other side because I don't want it over there. I don't have any b's on it. And I move this 3b over here. To now have all my b's on one side of the equal sign. I'm going to factor out a b, and I would have a plus c minus 3. And now that I have factors, and I'm multiplying, I can just divide. So b equals negative 10 over a plus c minus 3. Okay, if we look at number 7, on number 7, because I have this fraction, I'm going to follow my rule that I did up here with number 5, and I'm going to start by multiplying everything through by this 2. So if I multiply everything through by the 2, then the fraction on this side is going to go away. So I end up with 2/3 x plus 7 over 4. And then I distribute this 2 to everything on the other side, so I would have 6y minus 2. All right, so now I'm solving for x. So if I'm solving for x, I have to get rid of this 7/4. So 2/3 x equals 6y. Now I'm going to change this guy. I know I'm moving 7/4 over, so I'm going to say minus 8 over 4. That is that 2. Negative 2 is the same as negative 8 over 4. And then I'm going to subtract another 7 over 4 from this one moving over. Okay, so simplified everything. Now I want to clear this fraction. So if I'm clearing this fraction, I multiply by 3 over 2, which means I multiply this whole side by 3 over 2. So on the left side, everything cancels out, and it's just going to be x equals. And when I multiply here, I'm distributing this. This would give me 9y. So I have 18 divided by 2, which is 9. And then when I do this one, I cannot cross reduce, right? 3 and 4 don't reduce, 15 and 2 don't reduce. So I'm going to multiply across the top, which is 45, and I'm going to multiply across the bottom, which is 8. So not a pretty number here, but that's what we get. Okay, now this number 8 here is probably the hardest problem that we can do. I'm going to do this on paper, so I'm just going to move this over. Flip this over here. So my equation is I equals Pn over Rn plus A. Okay, and I'm solving for n, so I have an n here and I have an n here. Well, unlike these two b problems that we had here, where I can factor out a b, I can't factor out an n. I can pull an n out of the top. I can pull an n out of this part of my denominator, but I have this a. I can't pull an n out. So what I'm going to do is I'm going to take this entire denominator and I'm going to multiply it to the other side, right? So if I had something that looked like 7 equals x over 4, we would solve this by taking this 4 and multiplying it to the other side and have 4 times 7 equals x, right? So that's what I'm doing. I'm going to take this denominator right here and I'm going to move it up here. So this gives me I times Rn plus A equals Pn. I took the denominator and moved it up here. So now what I'm going to do is I'm going to distribute it, just like I normally would. So IRN plus AI equals Pn. Now, I know what the first thing that goes through your mind is, wait a minute, if we want all of the n's on the same side of the equal sign, here they're on the same side of the equal sign. But when I move it over here, now I have them on both sides. But what I want you to see is now that I move this up and distributed, I don't have this fraction anymore, and now I can move things over. So I'm going to move this n over here, and then this that doesn't have an n, ai, I'm going to move to the other side. So I have IRN minus PN equals AI. No, it doesn't. Equals negative AI because I subtracted it. So IRN, subtract PN, it comes over here. Subtract AI, it goes on the other side of the equation. Okay? And now my n's are on the same side, so I'm going to factor out an n. IR minus P equals negative AI. I can divide at this point. That is my final answer. Hold on. Let me move the camera a little bit. Okay, so here I factored out the n. When I factored out the n, I'm left with IR minus P. Now I can divide this whole thing, and the whole thing becomes a fraction. Okay? What you have to do is you have to be able to identify the patterns. When you see this pattern and you know you cannot pull an n out of every term, that's the only option, is to move it over here. Okay? And you're not flip-flopping places when you move it over, because if you move this, if you were to divide by I, then you still have this Pn in the top you have to do something with. Okay? All right, you're going to get lots of practice on these literal equations. I would probably say this is one of the harder sections in this unit, so come see me if you're struggling.